The hottest day in Earth's history is reported to have been on July 13, 1913, at Death Valley, California, where the temperature reached a blazing 56.7 degrees Celsius, or 134 degrees Fahrenheit. Now, compare this paltry number to the source of that heat, the Sun, which boasts a temperature of 5,505 degrees Celsius on its surface, while its core burns at 15 million degrees Celsius. The Sun is obviously the hottest thing in our solar system, but it is a mere candle when compared to several other stars and stellar phenomena, particularly supernovas. On the opposite side of the spectrum, colder temperatures come with a strict lower limit. The phenomena we're about to describe achieve stupefying temperatures that we have recorded. While breaking these barriers may seem impossible, by some technological advancement in science, they may be broken in the future. So, what are the hottest and coldest temperatures we've ever witnessed? Well, a supernova is a transient cosmic event that marks the last evolutionary stage in the life of a star. The star's life ends dramatically with a colossal explosion, the largest that occurs in space. The temperatures at the core during that explosion soar up to 100 billion degrees Celsius, 6,000 times greater than the temperature of the Sun's core. However, supernovae still aren't the hottest things in the universe, not even close. In fact, the hottest thing in the entire universe has been found, or rather created, somewhere you might not expect: Switzerland. In order to recreate the conditions that might have prevailed just moments after the Big Bang, physicists at CERN, Geneva, collided lead ions to form a Quark-Gluon plasma, a subatomic soup. The temperature, akin to the temperature that followed the titanic explosion of the Big Bang, reached a searing 9.9 trillion degrees Fahrenheit. That is 360,000 times the temperature of the Sun's core. But can we get any hotter? Well, yes, theoretically. The Planck temperature, which equals 100 million degrees Celsius, also known as absolute hot, is a temperature beyond which matter betrays its conventional behavior. Beyond this temperature, all four fundamental forces are unified into a single force. Simply put, weird and inexplicable things would happen. The coldest thing in the universe, on the other hand, is the Boomerang Nebula. To preface, atoms love heat. As the temperature increases, their motion does too. On the contrary, as the temperature plummets, their motion dwindles. We have never seen an atom achieve total rest, but theoretically, immobility is a possibility. As mentioned, there is a lower limit to temperature, where atomic motion completely ceases. This temperature is known as absolute zero, and has a magnitude of negative 273.15 degrees Celsius, or 0 Kelvin. The coldest spot in our solar system isn't actually very far away. The permanently shadowed craters near the south pole of the Moon measured around negative 240 degrees Celsius, or 33 Kelvin. However, the coldest natural spot in the universe is the Boomerang Nebula, which resides 5,000 light-years away from Earth. Its temperature is measured to be 1 Kelvin, or negative 272.15 degrees Celsius. But again, the coldest temperature we have come across was actually on our own planet, in an underground lab in Italy. Researchers of the collaboration Cryogenic Underground Observatory for Rare Events, CUORE, created a refrigerator that cooled at an astounding negative 273.144 degrees Celsius, or 6 millikelvin, so close to absolute zero, yet not quite there.